So, dear students, let us continue our discussion in refrigeration and air conditioning, and now we are presently in our second module. So, in the last class, we studied a small problem, how to solve a small question on vapor compression refrigeration system, and we studied how we will be using the data book and so on. So, before we move on to further problems in VCRS, now let us try to represent the VCRS or vapor compression refrigeration systems on this TS diagram and PS diagrams. So, depending upon the different conditions of the refrigerant. So, the refrigerant may be at different conditions at different stages or different parts of the VCRS. Depending upon different conditions. So, till now we have studied only the standard vapor compression refrigeration system, and we have represented it on the TS diagram and PS diagram. So, now let us move on to some other conditions of this refrigerant. Okay. So, in the first case, let us take at the compressor inlet and outlet, it is inside the wet region. That is, suppose the refrigerant is in the wet condition, that is, it is a mixture of both vapor and liquid at the compressor inlet and outlet. So, as per the notation that we have studied or we have followed till now, 1 to 2 is the compressor inlet and outlet. So, if it is mentioned that the condition of refrigerant is at the wet region at both compressor inlet and outlet, this will be the condition. Okay. So, now let us draw the TS diagram, marking TS diagram on the X and Y axis. Then after drawing the vapor dome, will be like this, the inverted belt shape in the TS diagram. So, point 1, that is at the compressor inlet, the refrigerant is given as the wet region. So, the wet region is inside the vapor dome. So, point 1 we can mark inside the vapor dome. 1 to 2 process will be the isentropic compression process. So, it will be vertical line like this, 1 to 2. So, here it is mentioned that at the compressor outlet also the refrigerant is inside the wet region. So, point 2 also will be marked inside the vapor dome. So, both 1 and 2 will be inside the vapor dome. So, 1 to 2 will be the isentropic compression process, followed by the constant pressure heat rejection step, that is the heat exchanger or the condenser process, 2 to 3, followed by our isenthalpic or constant enthalpy expansion process. Okay. Then followed by the refrigeration process, the refrigeration step, that is 4 to 1, the constant pressure heat absorption step. So, the same thing can be represented in the pH diagram like this. So, pressure in the y-axis, enthalpy along the x-axis. So, the inverted vapor dome, it will be having a tilted shape in the pH diagram. So, again, following the same notation that we followed in TS diagram, 1 to 2 will be the compression process. So, point 1 is the compressor inlet, point 2 is the compressor outlet. Both are in wet region. So, point 1 and 2 will be inside the vapor dome, So, 1 to 2 process will be our isentropic compression process like this. Then 2 to 3 our constant pressure heat rejection or the condenser process. Then 3 to 4 it is our constant enthalpy expansion process. So, 3 to 4 will be a vertical line in our pH diagram. Then 4 to 1 will be our constant pressure heat absorption step or our refrigeration step. So, this will be the representation of the refrigerant condition inside the wet region. Suppose the refrigerant is inside the wet region at the compressor inlet and outlet. So, this will be the TS diagram and pH diagram for that. Now, let us move on to another condition where at the compressor inlet, the compressor inlet is in the wet region and the compressor outlet is in the dry saturated region. So, here we are always representing the condition of the refrigerant. Okay. So, here at the compressor inlet, the refrigerant is in the wet region, and at the compressor outlet, the refrigerant is in dry saturated region. So, what will be that? The wet region means the compressor inlet, that is point 1, will be in the inside the vapor dome. So here in the TS diagram, point 1 will be inside the vapor dome. In the pH diagram also, the point 1 will be inside the vapor dome. Then what is mentioned here, the compressor outlet is in the dry saturated region. So after compression, that is 1 to 2 or 1 to 2 here, after compression process, the refrigerant is in the dry saturated vapor condition. So where we can mark the dry saturated vapor condition or point 2, the point 2 will be marked on the vapor dome. So the topmost point of the vapor dome will be the critical point, and below that, towards the right side, it is the the saturated vapor condition. So we can mark the point 2, that is the compressor outlet in the dry saturated vapor condition, as like this. So point 1 will be inside the vapor dome. So point 1 will be inside the vapor dome, followed by point 2 on the vapor dome. Okay. So point 2 will be on the vapor dome. Then followed by our 2 to 3 process, that is the condenser process, the constant pressure heat rejection process. So point 2 to 3, it will be the constant pressure heat rejection process, followed by the 3 to 4, that is our constant enthalpy constant enthalpy expansion process or isenthalpic expansion process, like this in our TS diagram. 3 to 4 will be a vertical line in our pH diagram. Okay. Then followed by our refrigeration step, that is the constant pressure heat absorption step, that is 4 to 1. The 4 to 1 process will be the constant pressure heat absorption step, that is 4 to 1. So this is how we will be representing such a condition like this, that is the compressor inlet is in the wet region and the compressor outlet is in the dry saturated region. This will be the representation, the TS diagram and pH diagram. So now let us move on to another condition where the refrigerant may be in some other condition, that is, suppose the compressor inlet is in the wet region but the outlet is in superheated region. So during the compression process, at the inlet of the compressor, that is the point 1, it will be in the wet region, that is inside the vapor dome. So in the pH diagram also it is inside the vapor dome. But during the compression process, in some practical case, even though the at the inlet, even though the refrigerant may be in the it will be in a mixture of liquid and vapor condition. But during the compression process, it may shoot up to the superheated vapor form. Okay, at the inlet or the start of the compression, the refrigerant may be in both liquid and vapor condition, but during the compression process, the refrigerant may be turned into a superheated vapor form. So superheated vapor form will be outside the vapor dome. So point 2 will be marked outside the vapor dome, like this. So 1 to 2 will be isentropic compression process, which can be marked in the TS diagram like this. So the point 2 will be marked outside the vapor dome in the pH diagram also. So 1 to 2 process will be marked, that is the isentropic compression process will be marked like this in the pH diagram. So the other processes are remaining same. 2 to 3 process will be the constant pressure heat rejection or the condenser process. So it will be like this in the pH diagram. Then 2 to 3 process, it is a constant pressure line. So a constant pressure line in the TS diagram will be appearing like this, from superheated state first to saturated vapor, then followed by turning it into saturated liquid. So 2 to 3 line will be appearing like this in the TS diagram. 3 to 4 process will be our constant enthalpy expansion process. Constant enthalpy expansion process 3 to 4. Then the constant enthalpy expansion process will be a vertical line in our pH diagram, followed by our refrigeration step 4 to 1. 4 to 1 here, it is the constant pressure heat absorption step, that is our refrigeration step. Now let us move on to another condition where the refrigerant is dry saturated vapor at the compressor inlet. The refrigerant is dry saturated vapor at the compressor inlet. that is nothing but we have already studied our standard vapor compression refrigeration system or standard VCRS. We have already discussed how we can mark such a standard VCRS in our TS diagram and PS diagram. So again let us discuss. So it is our vapor dome here. Point 1 will be the compressor inlet or the starting point of the compression. At the starting point itself, the refrigerant is the compressor inlet itself is the refrigerant is dry saturated vapor. So point 1 we can mark on the vapor dome. So point 1 we can mark on the vapor dome in our pH diagram also. Then point 1 will be followed by point 2, that is 1 to 2 will be our isentropic compression process like this in the TS diagram. 1 to 2 will be the isentropic compression process in our pH diagram also. Then followed by 2 to 3 our constant pressure heat rejection or the condenser process. 2 to 3 in the pH diagram, 2 to 3 in our TS diagram. Then followed by 3 to 4 our constant enthalpy expansion process. 3 to 4 in our TS diagram. 3 to 4 will be a vertical line in our pH diagram. Then followed by our refrigeration step, that is nothing but constant pressure heat absorption step. That is the refrigerant will be absorbing the heat at a constant pressure 4 to 1. 4 to 1 can be represented in pH diagram like this. Then another condition where the refrigerant may be a superheated vapor at the compressor inlet. So due to certain circumstances which we will be learning in our one of our problems, the refrigerant itself may become a superheated vapor at the compressor inlet due to some reasons. Okay, so point 1 we can no longer mark it on the vapor dome but outside the vapor dome. Okay, so point 1 we can mark outside the vapor dome like this, followed by the isentropic compression process like this. Okay, so point 1 we can mark outside the vapor dome in pH diagram also, so followed by the isentropic compression process like this. Then the other process are remaining same. 2 to 3 it is our constant pressure heat rejection or the condenser process. 2 to 3 it is the constant pressure heat rejection process, condenser process. So 3 to 4 it is our constant enthalpy expansion process. Okay, so 3 to 4 can be marked in pH diagram also like this. Then followed by our 4 to 1 process. It is 4 to 1 process. Always you remember it is the constant pressure heat absorption step. So the constant pressure line, a constant pressure line in our TS diagram will be always like this. The constant pressure line will be a horizontal line inside the vapor dome, because it is having the phase change. Phase change is represented inside the vapor dome, and that is happening at a constant temperature. That is why it is a horizontal line in the TS diagram. But after this crossing the vapor dome, after it has become vapor, the constant pressure heat addition step, absorption step, it will be slowly increasing its temperature. That is, after becoming saturated vapor, again if you are adding heat, the temperature of the saturated vapor will increase, and that is represented like this. So the constant pressure heat absorption or refrigeration step will be a horizontal line followed by inclined line like this. Okay, but here in the pressure enthalpy diagram, the constant pressure process will be always a horizontal line. That is why 4 to 1 process will be represented like this. Okay, so these are the various representation. This is how we will be representing different conditions of our refrigerant at different parts of the VCRS. So we will be using these representations in our coming sessions. Thank you.